All right, guys, so what we're going to do is just review some of the basic probability concepts that we learned in 8.1 and mostly 8.2 because 8.1 was kind of just seeing some probability games that we could play. But we're going to start out with just talking about the NHL, which is the National Hockey League. And I don't think a lot of you know everything about the NHL, so something like this would require you to do a little bit of research, just like the problem you're going to be asked to do on your own. It's probably going to require a little bit of research as well. But we're going to say that N is the set of all teams in the NHL. So you're probably going to want to do a little research and figure out how many teams there are in the NHL. It turns out that the NHL, if I listed out the teams, has 31 of them. And so you could list each of those teams, right? There's Arizona, there's Buffalo, and so on, right? All the way down to a team called Winnipeg, and there are 31 teams. So however you want to organize this, that's your set N, right? And we don't need this to be described as NHL. We could just call it N. So that's the set of N. There are 31 elements in N. C is a subset of N. I'm going to put C here. And contains all teams located in Canada. So for this, you'd have to do a little bit of research and find the teams that are in Canada that are also in the NHL. And so that's a shorter list. All right. I'm going to list those out here, but you would have to do a little bit of research to figure out which teams these are. So you don't have to list them all out, but there aren't so many of these. There are only 7 teams that play in Canada that are also in the NHL. And then we've got another subset, which is called E. And E is all the teams that are in the Eastern Conference. So we'd have to do a little bit of research and find out which teams are in the Eastern Conference. And it turns out there are 15. All right, so there's a whole bunch of them. And I may have misspoken a moment ago. There are 16 of these teams. So now I've got a list of all the elements, and I should probably be looking at all of these, on my computer, phone, or whatever when I calculate these probabilities. Because I want to know what the probability is that I choose a team at random and it is a Canadian team. So we'll go back to that formula that we discussed at the very beginning of the unit. Any probability of any event is just going to be the number of desired divided by the number of possible. So in this case, the number of possible outcomes is the number of NHL teams, because C is a subset of N. So of those NHL teams, of which there are 31, how many of them are Canadian? 7 of them, because we've got a set there of 7 teams. When we discuss the complement of the set, which is what this refers to, we're asking how many teams are not in C. What's the probability of choosing a team at random that is not in C? And so for that, we just count up all the teams that are not Canadian. And in this case, if I count up every single team in the NHL that isn't Canadian, there are 24 out of 31. And remember, we could check to confirm that that's the case by using that little formula we came up with at the end of 8.2, which says that if I add the probability of a set to its complement, that's got to add up to the whole set, the greater set. So let's make sure that that's the case. The probability of C is 7 teams out of 31, and the probability of not C is 24 teams out of 31, and that has to equal all 31 teams, and it does. So it looks like our complement checks out there. The probability of E is the probability of choosing a team at random that's in the Eastern Conference, and if I count all those up, we said there are 16 out of the total 31 NHL teams. And so its complement is going to be all the teams that are not in the Eastern Conference. And if I count those up, I get 15. And so to check, again, you could add those. 16 plus 15 is 31 out of 31 teams. So that is all our teams. And so this is sort of the last thing that we discussed, is just the idea of calculating the probability of an event that might be a subset of a greater event, and then the idea of those events having complements. This is a thing that we dealt with a little bit. What we didn't talk too much about is these and or situations, which is what tomorrow's lesson is going to be on. But I do want to introduce you to that concept here and just think about how it is that we would actually figure out these elements. So if you're asked to find the probability of randomly selecting a team that is in Canada, so in set C, and is in the Eastern Conference, so in set E, what would its probability be? Well, logically, we can reason our way through this, and that would have to be out of 31 teams, and that's going to be all the teams that are both Canadian and in the Eastern Conference. And so I could do a little research, and I would see that of these Canadian teams, Toronto, Ottawa, and Montreal are the only three that are also in the Eastern Conference. And so that would mean that the probability of selecting a team that meets both of those requirements is 3 out of 31. It's different if we're calculating the probability of randomly selecting a team that is in Canada or is in the Eastern Conference. And again, this is a thing we're going to get more into tomorrow, but this is a different question because now when you think about who meets these restrictions, it's a much larger number. For example, is Edmonton Canadian or in the Eastern Conference? Yeah, but they're not in the Eastern Conference. They're only Canadian. They do count here, however, because they are one of these two things. So Edmonton counts, Toronto counts, and they happen to be in both. Ottawa counts, they're also in both. Vancouver counts, they're only Canadian. Buffalo counts, they're only an Eastern Conference team. So in order to figure this out, we have to take all of the elements in both of these sets and figure out if it's an element that's in either C or E, then it belongs in this set. So when I count all these up, I'm going to count up all of the teams in the Eastern Conference. There are 16 of those. Remember, when you count up these 16, you've already included these 3 teams because they already are in the Eastern Conference. So it's those 16 plus 1, 2, 3, 4 more. So that would have to be 20 teams. And we're going to talk more about that concept tomorrow. You're going to do an exercise just like this on your own later, and you're just going to scan and submit your work. But this is a very similar process to what you're going to do later. The exercise you're going to do later is going to deal with football. I'm sorry if you're not a big football fan, but you'll be able to look up the numbers that you need to look up online pretty easily.